Hi, and welcome to this course Leveraging AI Insights and Text Analytics in Power BI. My name is Janani Ravi, and I'll be your instructor for this course. Power BI's AI capabilities offer a remarkable blend of data analytics and artificial intelligence, revolutionizing the way businesses harness insights from their data. With features like AI powered data transformation, natural language queries, and automated machine learning, Power BI empowers users to unlock hidden patterns, generate predictive forecasts, and gain a deeper understanding of their data without requiring extensive data science expertise. You'll start this course by generating insights on data and reports. You can generate AI based insights of three types: anomalies, key performance indicators, and trends. You'll explore how to generate these insights on datasets, reports, and even dashboard tiles. You'll also learn how to harness AI to explain fluctuations and variations in your data. Next, you learn how to perform text analytics in Power BI. Power BI integrates with Azure Cognitive Services on the Azure Cloud Platform to allow for text and image analytics. You'll explore how you can use the text APIs for language detection, key phrase extraction, and sentiment analysis. Finally, you'll use image analytics in Power BI. You'll use the image tagging API, which will allow you to label an image with tags with the help of artificial intelligence. You will load in a dataset of images and generate tags for each image in your data. In conclusion, this course will provide you with a solid understanding of how AI based features can be leveraged in Power BI. Hi, and welcome to this learning path on leveraging artificial intelligence in Power BI. Now, likely you're familiar with Power BI, Microsoft's business intelligence tool that makes it very easy to clean, process, transform, and visualize your data using reports and dashboards. Over the last couple of years, Microsoft has introduced a whole host of artificial intelligence powered features in Power BI, which makes it very simple for you to generate great visuals, narratives for your data, reports, and dashboards. Artificial intelligence is not a separate feature in Power BI. Instead, AI powered visuals, AI powered reports, AI powered narratives, AI powered models, these are integrated into the Power BI service as well as Power BI desktop. Features that leverage AI empower data analysts to glean even more insights from their organization's data without them having to do all of the hard work themselves. Here are the AI features that we'll cover in this learning path, starting with insights generation. Power BI has a feature called Quick Insights that can generate data insights on your dataset automatically. You can run quick insights on an entire dataset or a specific dashboard tile. Quick Insights uses various algorithms to search for trends and anomalies that exist in your dataset and generates interesting visualizations based on your data. Insights helps you easily explore and find information in your data such as anomalies, trends, as you interact and consume your reports. We'll also explore text and vision based analytics available within Power BI. Text analytics allows you to apply different algorithms from Azure Cognitive Services to enrich your data within Power Query. The following services are currently supported as a part of text analytics: sentiment analysis, key phrase extraction, language detection, and as a part of vision analytics, image tagging is currently supported. We'll explore all of these in our demos. Power BI also supports a host of machine learning models that you can build and train on your data. You can use automated machine learning that is part of Azure Cloud Platform to automatically generate a machine learning model. AutoML currently supports three different types of models: binary classification, where you classify records into one of two categories; general classification or multi class classification, where you classify records into multiple categories; and regression, where you predict a continuous value. Once you train a model, Power BI automatically generates a validation report that you can use to interpret and understand your model's results. Power BI also leverages artificial intelligence for anomaly detection. Anomaly detection helps you enhance your line charts by automatically detecting and plotting anomalies in your time series data. In addition, you can also get explanations for the anomalies in your data to help with root cause analysis. The AI algorithms for anomaly detection plot the expected range for your values, and then anything outside of this expected range is tagged as an anomaly. Power BI has several AI powered visuals that can help users gain insights from their data. We'll explore and study two different AI powered visuals. The first of these is the decomposition tree. The decomposition tree enables us to visualize data across multiple dimensions. The second AI powered visual we'll study is the key influencer chart. This helps identify what factors drive the metric that you're currently analyzing. This will help you identify hidden patterns in your data that could influence your business decisions. We'll then explore smart narrative summaries. This is a feature in Power BI that allows users to provide a quick text summary of visuals and reports. These narratives provide relevant insights that can be customized to address key takeaways, point out trends, and edit the language and format for a specific audience. These summaries can help explain key insights in your data to others viewing your report. We'll then explore the Q&A feature in Power BI that allows users to explore their data using natural language queries. Q&A is interactive and fun, and it makes analyzing data very simple and intuitive. And finally, the last AI powered feature that we'll explore will be Copilot for DAX calculations. This allows us to create DAX formulas for measures that we can then include as a part of our table. Let's understand each of these AI powered features in turn, starting with insights. Insights analyze the data that is present in Power BI and identifies interesting trends and patterns that exist in the data. If you had to analyze your data manually, it's quite possible that there might be certain insights that you miss because you simply don't think about exploring those variables. With auto generated quick insights, well, you have someone else helping you identify interesting features in your data. The Quick Insights feature is available for individual visuals that are embedded within your dashboards and reports. You can also generate these quick insights for entire reports or for a dataset that you uploaded to the Power BI service. Insights help you with a number of different kinds of analysis. You can identify outliers or anomalies in your data, correlations that exist in your data, trends, seasonality, and variables that have low variance. Text and vision analytics in Power BI are available as a part of Power Query. Text analytics uses Azure Cognitive Services to run analysis on your data within Power BI. Now, there are three different text analytics algorithms available in Power BI. The first of these is language detection. The detect language function evaluates the text input you provided, and it'll figure out what language the text is in. It'll detect the language name and its corresponding ISO identifier, and it supports a total of 120 languages. The next text analytics feature that's available is key phrase extraction. This function will evaluate the text that you provided and identify key phrases or important keywords in the text. And this works best on larger chunks of text with lots of key phrases. The third text analytics feature that's available is sentiment analysis. The score sentiment function returns a sentiment score for the text input that you provided. The sentiment score ranges from 0 to 1, where 0 expresses negative sentiment and 1 expresses positive sentiment. And sentiment scoring works best on small chunks of text. And the fourth feature here is a vision API that allows us to tag images. This returns tags for images that you input via URLs based on 2000 recognizable objects. It can also provide hits for unrecognizable images. You can also train machine learning models using the Power BI service, and this integrates with automated machine learning on the Azure cloud platform. This automated ML pre-processes the data that you have in Power BI, trains a machine learning model, and you can then use it to get predictions. There are three categories of models that are supported: binary classification, where you categorize records into two categories. So the only possible output for a record is one of the two categories. Another supported machine learning model is multi-class classification, also known as general classification. This allows you to categorize records into three or more categories. And finally, the third kind of model that is supported is a regression model that can be used to predict a continuous variable. Anomaly detection in Power BI uses an artificial intelligence based algorithm to detect anomalous or outlier values in time series data. Now, the time series data that you plot using line charts, you can enable anomaly detection for this data, and your outliers will be plotted on the chart itself. Anomalies are values outside of the expected range for the metric that you are analyzing. Now, in addition to detecting anomalies, the anomaly detection algorithm also provides explanations for the anomalies and helps you with root cause analysis. Multiple visuals in Power BI leverage artificial intelligence, and the first amongst the visuals that we'll study here in this learning path is the decomposition tree that allows you to drill down into a particular metric that you're interested in using the different dimensions that exist in your data. With the decomposition tree, you can manually drill down into dimensions that you select and view aggregations for these metrics in each of these dimensions, or you can use AI splits to determine how to drill down into dimensions. This will allow you to select the next dimension to drill into based on whether you want to analyze high or low values of the metric that you're interested in. Another AI powered visual that we'll work with is the key influencer visual that helps you identify what factors drive a metric. Let's say you have the records of all the home price sales in a certain area. Key influencer visuals will allow you to see what factors influence the price of homes in the positive or negative direction. Key influencer visuals use AI to compute factors and the relative importance of factors driving a particular metric. Next, we look at smart narrative summaries. These are quick text summaries of visuals and reports identifying important insights that exist in your data. The cool thing about these summaries is that they're dynamic and not static. So, as the data in your visuals refresh, the summaries will also be refreshed. So, the summaries are live summaries. These narrative summaries can be filtered and viewed for specific parts of the data in which you want to focus. So, let's say you want to drill down into data for a particular year, your narrative summaries will reflect only the trends and insights for that particular year. We'll also see how the natural language Q&A widget works within Power BI. Natural language Q&A indexes and searches your dataset and allows you to ask questions using intuitive natural language queries. Natural language Q&A is supported and accessed using a Q&A visual that you can embed in your report or using the Q&A feature on a dashboard. You can also teach the Q&A feature terms and queries that are specific to your organization, allowing you to use organization specific terms in your queries. And the last AI powered feature that we'll cover in this learning path will be Copilot for DAX calculations. Copilot is Microsoft's AI assistant that is integrated with Power BI to help analyze your data. Copilot makes available a whole host of features that are in private preview at the time of this recording, but what's publicly available is using Copilot to compute quick measures on your data. You can use natural language queries to generate DAX formulas to compute measures on your dataset. The AI features in Power BI allow you to generate quick insights on your data. And in this demo, we'll see how that works on a dataset that you uploaded to Power BI service. Here I am in Power BI service. I'm going to head over to workspaces and create a new workspace within which we'll perform all of the analysis here in this learning path. I've called this workspace AI Analysis Workspace because we are primarily looking at AI features. I'm going to go ahead and hit apply, and my new workspace has been set up for me. The first dataset on which we'll generate insights is this AWS SaaS sales dataset available from this link here on Kaggle. Now, this dataset contains a number of records for the sales of different software as a service products from Amazon. So for each sale, we have the order ID, the order date, the country, city, region, sub-region, the customer, the segment, the product that was sold, and the actual sales number, the discount, and the profit. As you can see, it's a fairly large data set with several columns. And really, if you had to generate your own insights on this data set, it's going to be tough. That's a lot of analysis that you'd have to do on your own. And really, you can save a lot of effort by using AI generated insights. I'm going to upload this dataset to my workspace here on Power BI service. Go to New Dataset. I select CSV as an option because the data is in the form of a CSV file on my local machine. Click on Browse this device and I select the AWS SaaS Sales CSV file. Once you click on Open, in a matter of a few moments, the dataset will be uploaded to the Power BI service and will be available to you for reports, dashboards, and quick insights. Click on the three dots next to the dataset, and this will bring up a menu, and there you'll find an option that says Get Quick Insights. These are AI generated insights for your data. AI insights in Power BI will scan the dataset that you've uploaded and extract all kinds of insights and relationships that might exist in your data. It'll scan all of the columns and generate charts with interesting visuals, things that you might want to pay attention to. You'll see here that all of the generated insights are in the form of a chart or a visual. In addition, you have a narrative summary off to the right, highlighting interesting details in that visual. For example, here in this first line chart, profit by customer ID shows you the profit for different customers for America as a region. And you can see that there are outliers here. In addition to line charts, there are scatter plots, there are bar charts, and many other types of visuals. Here is a bar chart that has visualized the number of customers that the records show in different cities. And you can see that London has noticeably more customers in the sub-region UK, Ireland as compared to other cities. Let's select a few charts and I'll show you how you can generate these charts on your own. Here you can see that there are a few customers that have been incredibly profitable. This might be an indication to you that these are the customers you might want to focus on for next year's sales. What I'm going to do now is open up the Power BI service on a new tab and in the same workspace, create a report and I'll show you how this particular chart can be reconstructed. In this way, every chart that you see generated as a part of the insights can be reconstructed by you. I'm going to select this dataset and select Create Report. And within this report, I'll manually reconstruct the chart that we just saw, showing us the customer outliers for the region America. The chart that was displayed was a line chart. So I'm going to select the line chart option here. Along the x-axis of the line chart, we had customer ID. So drag customer ID onto the x-axis. Along the y-axis, we had profitability. Select the profit column and drag that to the y-axis. Now there is an additional bit of filtering that you might need to perform. If you remember, that chart only displayed customers for America, which means you need to filter by region. Select the region column and drag that to the filter pane here, and within the filter, select America as the region. And now essentially we have the same chart that you saw in the AI insights. Now, for you to have extracted this particular insight would have been very difficult because there's so much analysis that you need to do. But AI insights does these analysis for you automatically. Now, let's go back and explore the AI generated insights for SaaS sales once again. Like I said, there are charts and there are narratives. Here is a line chart which gives us the count of country by order year, and country is trending upwards for segment enterprise, which means that we are selling enterprise based products to many more countries over the years, which is a good thing. Here is another chart that shows us useful sales analysis, count of customer by city, and here you can see that in the UK Ireland region, London is an outlier, and Glasgow, we don't really have that many customers from there. Let's switch over to our report and let me show you how you can recreate this chart as well. This is a horizontal bar chart or a horizontal column chart. Make sure you have city along the y-axis and make sure that you count the number of customers along the x-axis. The same customer may have ordered different products, so make sure you use count distinct rather than just plain count. Now we need to perform an additional bit of filtering here. We need to filter by sub-region because London has the highest number of customers in the UK Ireland sub-region. So drag the sub-region onto the filter pane and select UKIR. And there you can see the same chart that we saw previously in the AI generated insights. I'll just format this visualization to turn on data labels, and you can see that London has over 90 customers. Whether you're generating insights using reports or using AI generated insights, you can pin these visuals to a single dashboard. Let's say I pin this visual to the AWS SaaS Sales Insights dashboard, count of customer by city. I can now head over to the report and pin the visual that I had generated there as well. I'll just save this report before I actually do that with a meaningful name. This is the AWS SaaS Sales report. We'll keep this around to create visuals that we are curious about in the AI generated insights. Now that we've saved this report, let me pin this visual count of customer by city to the same AWS SaaS Sales Insights dashboard. And now you can head over to this dashboard and you can see the AI generated insight and your own visual side by side. You can see that they're exactly the same. Let's go back to exploring the AI generated insights. Here is a bar chart showing the count of industry by city for the country Russia, and Moscow and St. Petersburg have noticeably more industries who've signed up as customers for the SaaS sale products as compared with other cities here in Russia. Let's scroll further down here, and here you can see an interesting donut chart, profit by region. And here it's very clear that EMEA accounts for the majority of profits made based on the records that we have. Europe, Middle East, Africa accounts for 50% of the profit. If you scroll further down, you'll be able to see the profitability by country. And here you'll be able to see which countries are profitable or not. And this has been filtered by the subregion EU West. And it's clear here that the products sold in the country France have been loss making, whereas products sold in the country Spain have been incredibly profitable. Now, this might lead you to think that maybe it's just profitable to sell in EMEA as compared with other regions. But another thing that you can see here in the count of country by region is that these products are sold to many more countries in EMEA as compared to APAC, Japan, and America. So it's likely that we just have more customers in EMEA. Another way to dice up profit is by sub region, and here you can see that North America and UK Ireland are more profitable than some of the other sub-regions. It's pretty clear that these AI generated insights on our dataset are very, very comprehensive. I'm going to scroll down here to a bottom to another donut chart that I found interesting. Here you can see that the majority of the profit in the America region comes from North America and not from LATAM. The SaaS sales data also contains product information, and here you can see that the marketing suite product has been loss making, whereas all of the other products have been profitable, some more than others. Alchemy seems to be the most profit making here. I've shown you how you can generate insights using your dataset. I've shown you how these insights are very wide ranging and you can actually recreate these insights in your reports if you want to. You've also seen that you can pin these insights to dashboards. Now, I'll leave it to you to explore the remaining insights on your own because there are so many. And now that I've given you a peek of what's possible, you'll be able to explore the rest on your own. Now, once you've generated insights on a data set, unless you change that data, those insights will be available for you to view at any point in time. So let's go back to the main analysis workspace. This is our AI analysis workspace. And now, if you were to click on the three dots here, you'll see the option for View Insights. You'll be able to view insights that have already been generated. Those insights are always available to you using this option here in your dataset. And let's say you were to update your dataset, well, you can regenerate the insights. We've seen that Power BI can create AI generated insights by just looking at your data, analyzing it, slicing and dicing it in different ways. Power BI then visualizes all of these insights that it has extracted from your data, and in addition to visuals, also provides helpful narrative summaries telling you what exactly Power BI has observed. It's pretty clear that you don't play much of a role here in generating these insights, but you actually have a lot of control over the quality of insights generated. You need to optimize your data in such a way so that quick insights from Power BI actually generates useful insights. And in this demo, we'll see how you can optimize your data. The dataset that you're looking at here is the Global Superstore dataset. The Global Superstore is an e-commerce site that ships products to customers in different countries across the globe. They have customers in every continent and almost every country. I downloaded this dataset from this link here at Kaggle, but I made a few changes to the data so that it's not really in an optimum format for generating AI insights. Let me highlight some of the things that are not really great about this data. Now we have the row ID, which is not really useful. It's just a unique way to identify each record, but we can do that with the order ID. So that's a duplicate. You don't really need the row ID information. The presence of these extra columns could mess up insight generation because insights will then assume that these columns are meaningful. Any column that exists in your data, insights will try and use. Notice that we also have the first name and last name for each customer. These are categorical variables as far as the AI generated insights algorithm is concerned, and they'll be treated as such. But really, I'm not sure they're meaningful. We have extra columns here, columns that contain the same information. For example, columns O and P, subcategory and type, contain the exact same information. And really, duplicating of information makes insights worse. Now we have a bunch of other information. Notice that we have an address column at the very end, and the address is just city, state, and country. Now we don't have the granular address details. We don't have city separately, state separately, and country separately. This means that AI insights will not be able to extract granular city, state, and country information from this column to give you country specific insights or city specific insights. Now keep this in mind and while I use this data to generate quick insights. I've headed over to the Power BI service here and I'm going to create a new data set. This is going to be a CSV data set and we'll select the global superstore CSV file that's present on our local machine. We'll first take a look at the insights generated using this non-optimal dataset, and then we'll clean up the data and look at the insights, and you'll see the new insights are so much better. Let's head over to the AI analysis workspace. You can see that the global superstore dataset has been uploaded here. Clicking on the three dots here will bring up a menu where you can then select Get Quick Insights. And you might have to wait for maybe 10-20 seconds before the insights are generated. And once that's done, click on View Insights and let's see what insights have been extracted from this data. And you'll find here in this generated report that some of the insights are useful. You can see that standard class shipping accounts for the products which give us the majority of profit. That's definitely interesting. Here is another one. You can see that critical shipping costs more than other kinds of shipping. Maybe this was obvious, but it's good to have it in the form of a chart here. Notice this chart, profit by first name. Now I'll leave it to you to figure out whether this is really useful. According to the narrative summary, Grant has noticeably less profit. So for people who had the first name Grant for our customers, we've had negative profits or losses, but people with the first name Bill have proven to be incredibly profitable. Now, as you might imagine, this is a completely useless and meaningless insight, but it is part of our generated insights because essentially AI insights treats first name as a categorical variable. Here is another completely useless insight, count of first name and count of customer ID. Now, our customers are likely to have very different first names, and this scatter plot tells us a linear relationship exists between first name and customer ID, and really that's completely meaningless. And these meaningless charts are interspersed with more meaningful charts. For example, this one is a meaningful chart. Across the years, office supplies has held a steady percentage of the total profit made by the global superstore. This is interesting, but count of last name by ship date? Well, unless you're trying to figure out whether there is some fraud going on, this is not really going to help. And really, if there are fraudsters, they won't use the same last name. Again, it's hard to say that all of the insights are meaningless. Profit and average of shipping cost by postal codes identifies some outliers where profit and shipping cost are both high. Well, that's a great insight. Oh, here's something that you can do when you find insights that are meaningful. You can click on this little arrow here and enter something known as focus mode. And focus mode allows you to zoom into a particular visual that has been generated by AI insights. On the right, you can also see all of the filters that have been applied to this visual. So this gives you an idea of how this visual was constructed. Now, going back, profit by order priority. Okay, this is definitely a useful pie chart, but here I have count of last name and count of first name. Again, another meaningless relationship. I think you've got the point here. If you have columns that don't make sense in your data, those will end up being used to generate insights that are not meaningful, which really might prevent the artificial intelligence algorithm from looking at other meaningful columns. That's just one part of the problem, these meaningless charts. Another part of the problem with these generated insights here is the fact that there are insights that could be useful that are not available because the data is not set up correctly. For example, I might want to know the profitability by country or sales by country. That information is not available here. I might want to know the profitability and sales by state or by city. All of that information is not available because city, state, and country has been clubbed together in a single column. And AI Insights is simply not able to work with that. Now I'm going to head back to my workspace and get rid of this global superstore dataset the way it exists right now. This was not really that useful because there's a lot more we can do to optimize this data before we use it for AI generated insights. I've opened up a new report here on Power BI desktop. I'm going to load the global superstore data into this report and then use Power Query to transform and clean the data. We'll then generate insights from the clean dataset and we'll see that the insights are so much better and just more meaningful. Click on Get Data here. You should find the text CSV option. Remember, our data is in the form of a CSV file. Select this, select the global superstore, open this data set, and load this into your report. Now, if you just click on load, that will load the data directly. But what we'll do instead is transform the data so that we can optimize it for AI generated insights. Now, the first thing to note here is this extra row ID column. That wasn't really used in the generated insights, but let's get rid of this column because we know that it doesn't really give us meaningful information. The unique order ID is sufficient to identify the individual records. Now we found that there were some categorical columns here that really caused a lot of meaningless insights to be generated, first name and last name. For the purposes of our analysis, we don't need this personally identifiable information. So I'm going to select and remove these two columns so that these two columns are no longer part of our data set. So I'm getting rid of columns so they're not used in insights. You can also choose to hide your columns in your data set and they won't be used in insights either, but I'm just going to get rid of these columns so they don't clutter up my data. Next, I'll quickly look at the column quality to see whether there are any columns with many missing fields. And immediately the postal code column jumps up at me. Most of the records for postal code have empty values, and really, if you have so many missing values, insights generated using postal code may not be meaningful. So I'm going to get rid of this column as well. Let's uncheck column quality. Next, let's see if we have any columns that are duplicates of one another, and for that, I'll use the column distribution. The column distribution will allow us to see at a glance if there are any columns that contain the same data. So I'm going to scroll over to the right and subcategory and type jumps up at me. 12 distinct and 1 unique. And if you quickly look at the column values, you can see that they are exactly the same. So subcategory and type contains the same data. So I'm going to get rid of one of these. Let's get rid of type. We are steadily moving towards a much cleaner data set. Uncheck column distribution. We no longer need this information. And let's see what other changes we can make. I'm going to scroll over to the right and address. That was a pain point. I did not get insights by country, city, and state because address contains all of these bits of information in a single column. You can see in this address column that city, state, and country are separated by commas. It will be possible for us to split this column using comma as a delimiter. Click on split column, choose the by delimiter option. You can see that it's selected the comma as a delimiter by default. Go ahead and leave that selection. And we want to split at each occurrence of the delimiter. This will extract the city, state, and country into separate columns. And that's exactly what you see here. We have 3 new columns instead of the original address column. Let's quickly rename these. The first column contains the city to which the order was delivered. We now have that in a separate column. The second column, address to, is the state to which the order was delivered. I'm going to rename that as state. And then I have the third column here that contains the country to which that particular order was delivered. So I'm going to rename this to country. Now, in the real world, there are many more data transformation and cleaning operations that you might want to perform. I'm going to do one last check before I consider this data cleaning process complete. I'm going to select all of the columns here and see whether there are any duplicates in my data set. First, I'm going to count the number of records in my data. So go to transform and count rows, and you can see that I have 51,306 records. Click on that little X mark next to counted rows and applied steps to get rid of this transformation, and let's perform removal of duplicates. For that, I'm going to select all of the columns once again so that duplicates consider all of the columns values. Right click and then select remove duplicates, and duplicates have been removed from our data. Let's go back and count the number of records now available, and we have 51,290 records. So there were about 15 or 16 records that were duplicates. Those have been eliminated. Duplicate removal is essential to ensure that any insights generated are actually correct and meaningful. You're not working on the wrong data. At this point, I'm fairly happy with our cleaned data. I'm going to close and apply the changes made in Power Query, and this transformed and cleaned data is now available within my Power BI desktop report. Now that we have our clean data, let's get this data over to the Power BI service where we'll generate insights. But before we do that, we need to publish this report. And even before that, we need to save this report with a meaningful name. Click on File and save this report with a meaningful name. Now, the report does not contain any visuals. I'm basically trying to get the data set published to the Power BI service. So I'm going to publish the entire report, and that will take the data set along with it. Click on publish, and you may need to log in if you're not already logged in. I am logged in. So I select the AI analysis workspace in my Power BI service account, and I publish this report along with the data set to the Power BI service. And now when I head over to the Power BI service, you can see the report and data set there. I'm not interested in the report, so I'm going to go ahead and delete this report. Click on the 3 dots and select the delete option. So I'll get rid of the report and we'll be left with the data set. Now the data set has the same name as the report, so I'm going to quickly rename it so it's a data set and not a report. Select the rename option in the 3 dots menu, and I'm going to call this just Global Superstore. We now have cleaned and optimized data that we can now use to generate insights. Let's do that and see how the insights are different. I'll now generate insights for this optimized global superstore dataset. Click on the 3 dots, and in the menu that comes up, select Get Quick Insights. And in a few moments, your insights will be available for you to view. Click on View Insights, and let's see if the insights have improved. Discount by category. Well, office supplies accounts for the majority of discount. That is a meaningful insight, but we could have got this insight earlier. Count of order ID by ship mode. Again, an insight we could have got with our non-optimal dataset. Now, even though these columns existed, such as profit by subcategory, the subcategory column existed, these insights are more meaningful because there are lots of irrelevant insights that are not generated by our AI algorithm. Let's scroll down further and see if we can view insights that would not have been generated earlier. Sales by country. This is extremely useful. You can see that the United States accounts for the bulk of the sales for the global superstore, whereas something like Equatorial Guinea or Armenia accounts for very little. This insight is only available because we cleaned and optimized our dataset. Let's scroll further down. Here is another insight that falls in this category: profit by state. The state information is only available because state is now a separate column. You can see that Texas is the least profitable state and California is the most profitable. It's pretty clear that this insight would have been lost to us had we not cleaned and optimized our dataset in order to extract city, state, and country information from the column where they were clubbed together. Here is another insight not available to us before: quantity by country. You can see that a large number of products are sold to the United States, France, Australia, Mexico, whereas there are other countries which do not have such a huge quantity of products. This is interesting enough that I'm going to go to the focus mode. Let's scroll down to the bottom. Equatorial Guinea, Armenia, Eritrea are all down there. Maybe it doesn't make sense to serve those countries if we can't have a good customer base there. Another interesting insight that has been generated thanks to our optimization and cleaning up of the data is discount by country. And you can see that the US gets many more discounts than some of the other countries here. I think there's one thing that's pretty clear here. If you want better AI generated insights, make sure that you get rid of unnecessary columns in your data, clean up your data, transform your data so that all of the information is available in the form of columns to Power BI's artificial intelligence model. And that will give you better insights overall. We've seen how you can have AI generated insights for a dataset. In this demo, we'll set up a report and see how you can get insights for the individual visuals in a report and also for the report page as a whole. I already have an AWS SaaS sales report here that I'd created in a previous demo. I'm going to get rid of this and create a new report. So click on the three dots and select the delete option and delete this report. We'll create a new report using the SaaS sales dataset. So I'm going to click on the three dots here, select the create report option, and let's set up a brand new report. Now I'll assume that you're fairly adept at creating reports. So I'll walk through the visuals for this report fairly quickly. The first visual here is a line chart. Along the x-axis, I'm going to place the order date, and along the y-axis, I'm going to place the sum of sales. This will give us the sales across the years for the individual dates. So this is a very granular representation of how sales have been for the global superstore over the years. I'm now going to add in some card visuals here in this first page of the report. The first card is going to contain the total sum of sales across all of the years. So select the sales column and drag that into the fields for the card visual. You can see that the total sales here is 2.3 million. In a similar manner, let me set up some additional cards with the total profit. So drag the profit column onto the fields here for the second card. You can see the profit is about $286,000. Now, the third bit of information I want, that is the total number of products that were sold across all of these years. Drag the quantity column onto the fields of this card so we can see that there are about 38,000 products that were sold. Let's add a bar chart here to see the total profit by country. So have country along the x-axis and drag the profit column from our SaaS sales dataset to be along the y-axis. So we can see how much profit we made across the different countries. You can see there are countries where we made losses as well. Now, the last visual I'm going to add to the first page of this report is a tree map. This tree map will contain the total sales based on product. So drag product into the category section here of this tree map and drag sales into the values section of the tree map. So we can see the total sales based on the different products that were sold. Now this report is going to have multiple pages. So click on the plus here at the bottom to set up a new page. And here I'll quickly set up a line chart that will have order date on the x-axis and the total profit on the y-axis. So we have the sum of profit by order date. I'm going to add a few filters here. So this shows me only the profit for the year 2022. So select order here, put it into the filters column here, switch over to basic filtering so we can filter by year and select 2022. So this chart now does not contain information across all of the records, only for the year 2022. add a third page to your report. And in this third page, I'm going to set up another line chart. But this line chart will contain both profit and sales numbers based on order date. This line chart shows two bits of information, profit as well as sales across the different years for which we have information. I'm going to set up a filter here as well. Notice filtering here already by date. I'm going to set up an advanced filter. I'm only interested in more recent dates in this dataset, only in those dates on or after June 1st, 2022. So use this drop down to select June 1st, 2022. We are only interested in orders placed after that date. Apply this filter. Now you might be wondering why I'm setting up my visuals so specifically. Well, you'll see that the insights actually take into account your visual and will give you insights for the date ranges that you've specified in your visual. So the filtering is also accounted for. I have one last page here, page 4, and here I'm going to set up a scatter plot. Here in the scatter plot, on the x-axis, I'm going to have the sum of sales, and on the y-axis, I'm going to have the sum of profit, and the value section contains the customer ID. This scatter plot shows me the relationship between sales and profit, and there is clearly a linear relationship here. Higher the sales, greater the profit. We now have set up our report successfully and we are ready to generate insights. Make sure you save this report. I go to File and Save, and I'm going to call this the AWS SaaS Sales Report. Now we have a report. Let's turn to generating insights. We've saved our report, and here I am on the first page of this report. In this reading view of your report, not in the edit view, in reading view, you'll get a link called Get Insights. And if you click on that link, insights will be generated for the current page of your reports. And you'll see three types of insights. Let me quickly collapse the section so you can see what the three categories of insights are. Insights are categorized into anomalies, trends, and KPI analysis. All three types of insights may not be present for all of your report pages, but this particular page of my report contains enough information so that we have insights across all three sections. Anomalies identify abnormalities in time series data, such as unexpected spikes and dips in the data. The insights algorithm will compute a boundary around what's considered to be normal or expected, and anything outside of this boundary is marked as an anomaly. Trends are also computed on time series data, and a trend occurs when there is a prolonged increase or decrease in your data over a period of time. The Power BI Insights algorithm first performs data smoothing, interpolation, time series sampling, a bunch of pre processing before it finds meaningful trends. Trends are also checked for statistical significance based on the slope and length of a change that you see in value. Noise and seasonality factors are removed. KPI analysis can use a target or not. We haven't really specified a target here in our report. So the KPI analysis will look at the values that we have in our report in the card visual specifically and flag values that are high or low compared to other segments. The All Insights section shows all of the insights that have been identified here in this page of the report. Or if you only are interested in the top insights, you can select the top tab. And here you can see there are just anomalies here in the top tab. Let's go back to All Insights and let's click on the other pages of this report. Notice that your insights actually change based on what page you're on. Here on this page, we only have anomalies and trends. We do not have any KPI analysis. That's because we just have time series data. We don't have any card visuals. Let's click through to page 3 of the report, and once more you'll find insights that are just anomalies and trends. No KPI analysis related insights were extracted because we have just time series data. Let's head over to page 4 where we have just the scatter plot, and here on this page the Power BI Insights algorithm was unable to glean any insights. At the time of this recording, most insights are extracted from time series analysis. Now that we have a big picture of the insights generated, let's dive a little deeper into the individual insights. Here on the first page of the report, I have lots of insights related to anomalous values of sales. And you can see that anomalies are split into recent anomalies, anomalies and significant anomalies. Recent anomalies are those where there was an unusually high or low value in the time series data recently, that is, towards the later years. So, if you're observing data over a long period of time, recent anomalies might be something that you're more interested in. Observe that as I hover over recent anomalies, the chart that was used to generate this insight is highlighted. The time series data, sum of sales by order date, was the one that was used. Anomalies are just anomalies that were identified across sum of sales. The same chart was used, and if you hover over significant anomalies, you'll see it was the same time series chart. Next, let's look at what chart was used to generate all of the insights related to trends. And once again, you'll see it is this time series charts. At the time of this recording, it's the time series chart that is the most relevant for extracting insights. Power BI used these card visuals that we had to perform the KPI analysis. When you hover over the individual insights here in this KPI analysis, you can see what card visual was actually used to extract this information. In all of the other pages of this report, we have just a single chart. So the data in that chart was the only one used to generate these insights. It's only the first page of the report where we have multiple charts. That's when we have multiple types of insights. Here we have just anomalies and trends based on this time series chart. And as we've seen before, there are no insights generated based on the scatter plot. Let's go back to the first page here and let's dive a little deeper into some of the insights that were generated. Let's take a look at anomalies. I'm going to click on Show More, and you can see we have recent anomalies, anomalies, and significant anomalies. Let's click through to the recent anomalies, and you can see that in the most recent data available, there was a high of sum of sales on December 3rd, 2023. You can see the natural language narrative at the bottom. Sum of sales was unexpectedly high on Sunday, December 3rd, 2023, with a value of 9951. All of the anomalous points here in this data are also highlighted here on this chart. In addition, here at the bottom, you have some possible explanations for these anomalies. What AI Insights tries to do is figure out why this anomaly might exist, and it tries to look through the other variables in your dataset to identify what might be the reason. One possible explanation seems to be that the sales to the tech industry was unusually high in this period, and you can see the sum of sales for tech highlighted in the darker blue color. And as you scroll below, you'll find other possible explanations for this anomalous sales in December 2023. Let's look at region is America, and you can see that sales in America was again unusually high during this period, highlighted in dark blue. Let's look at the strategic segment that also seems to have driven the high sales in December. You can see the dotted line in dark blue for December 2023. Those are sales to the strategic segment. Let's go further down. Let's take a look at product. It seems like the site analytics product drove some of the anomalous sales again in December 2023. But the most interesting possible explanation is the order month. It seems like sales spike in the month of December, and you can see that very clearly here in the blue bars. Every December, SaaS sales seem to spike, and this by far offers the best explanation, in my opinion. We drill down into a recent sales anomaly that was found, but the most significant anomaly across the entire time series data was the anomalous selling in the month of March 2020. I don't know about you, but whenever anyone talks about anomalies in March 2020, my mind jumps to COVID. And you can see there was a tremendous spike in sales around the time COVID spread around the world. You can see the narrative summary unexpectedly high on Wednesday, March 18, 2020. And here are the possible explanations. It seems like there was a huge spike in sales in the enterprise segment. So there was likely one enterprise customer who was actually buying products on that particular day. Another possible explanation seems to be order month is March. It seems like SaaS sales are strong in the month of March as well, and you can see that across years. Let's look at another explanation. Order year is 2020. You can see the sales for the year 2020 highlighted, and you can see that they are very high overall. This is the year people were working from home and tech companies sold a lot of SaaS related products. So that could be an explanation. Customer is Anthem. Now, Anthem seems to be the enterprise customer who really bought many products in March 2020. And you can see the spike corresponds to that customer. We drill down into two different sales anomalies in our data. Let's now look at a trend. The first insight here identifies an upward trend in the sum of sales, that is, total sales in the year 2020, starting in March 2020 and going through to December. And you can see that the trend clearly exists between Saturday, March 21st and Thursday, December 31st. Just like with anomalies, you also get possible explanations for why this trend might exist. And these explanations are backed up with very useful visuals. For example, the segment of sales seems to have driven this trend, and you can see how the different segments contributed. You can see that the enterprise segment accounted for the majority of increase. The narrative summary indicates that, and the big green bar that you see here in this waterfall chart, that also corresponds to the enterprise segment. Sales in other segments such as SMB and strategic fell, but enterprise rose much more. And you can see the same information using other visuals as well. This dispersion shows sales in March versus December, and you can see SMB and strategic are both on the red side, so they fell, they contributed less, but enterprise is way over on the green. Another visual here is a bar chart showing you the relative contributions of the different segments. You can see enterprise in blue really increased, whereas strategic in orange has really fallen between March and December. Another interesting visual that you have available to drill down into possible explanations is this ribbon chart. This ribbon chart shows you the contribution of the strategic segment in March and then how it has reduced and fallen all the way through to December. So, for every trend that is found in your data, AI Insights tries to figure out why exactly that trend might have occurred and tries to list out all of the possible explanations and give you different charts breaking down those explanations so you can really see what influenced the trend. Here is the waterfall chart for differences by industry. Communications accounted for the majority of the increase, whereas the decrease was driven by tech. We've drilled down into some anomalies and we've drilled down into some trends. Let's take a look at some of the KPI analysis insights that have been extracted. Here is the sum of sales analysis. This was generated based on the card that we have here in the report. We can see the current sum of sales, and it tells us that the sum of sales for the city, London, and other segments are significantly higher than others. It seems like London is an outlier in contributing to this value. Let's look at the sum of profit analysis. 7 segments have significantly lower sum of profit. So there are 7 segments that bear a second look, and 25 segments have high profit. So we should look at those as well. These insights help us drill down into our data further. Let's look at the sum of quantity analysis. There is one segment where not many products have been sold, so definitely that bears watching. The insights generated for your report are per page. So when you click on page 3, you'll get insights related to the visual here on page 3. You can see recent anomaly in sum of sales. This is the same thing that we drilled into earlier. If you remember, what's different about this line chart is that it contains sales and profit information starting June 1st, 2022, going all the way through the end of December 2023. Observe the significant anomaly in the sum of profit, which wasn't available in the earlier report because we hadn't plotted profit in a time series chart there. October 3rd was a profitable day. This allows us to drill down into what happened here on October 3rd. And as usual, there are possible explanations for why we had an anomalous value, that is, an extremely high value of profit for this day. Product is alchemy. There was a particular product that was sold that was very profitable, and we sold it to a large customer on this particular day. And this customer was based in India. By drilling down and really understanding these insights, you can extract valuable information from your data, and we really didn't have to do anything. There's a long trend here in sum of sales. We experienced a decline. Now, this decline was in 2023. Any decline is always worrisome. So let's see some of the possible explanations. And it seems like the fall can be accounted to sales that were made to the tech industry. That's the big red bar that you see here on this waterfall chart corresponding to decrease in sales. If you look at the scatter plot, you can see finance and healthcare industries increase their sales, but tech is very far in the red. At this point, I think we've explored enough so you know how to drill down into your insights and glean more information about your data. Here I am back in page 1 of my report. We've already seen how we can extract insights, and the insights will be generated for each page of our report. You can extract insights for specific visuals as well. Here I hover over my time series visual, sum of sales by order date, and I select the option Get Insights. Now this will generate all of the insights only based on this time series visual. We've already explored these insights before, so I don't need to drill down, but you can see that you can have insights generated for just a single visual if you're interested in drilling down further. Now, the only reason you'd include a visual in your report is because you're interested in that data, and insights is a great way to get additional information about that data. Here I have my sum of sales 2.3 million. Let me extract the insights associated with this particular visual in this report, and I get the sum of sales analysis indicating that the City of London is an outlier in sales. All of these analyses were part of the insights generated for the entire page of this report. I just wanted to show you how you can access the same information for individual charts. If you were to drill down and get insights for the tree map, well, there are no insights available within the context of this report. But you'll find that insights are available for this tree map when we look at it in the context of a dashboard. And this is exactly what I'm going to do next. I'm going to pin the visuals I'm interested in, starting with this time series data, to the AWS SaaS Sales Insights dashboard that we had set up earlier. Now, if you see that this dashboard contains just a single visual, I got rid of other visuals I had here in this dashboard. I'm going to go back to the report and pin the other visuals that I'm interested in. And once the dashboard has been set up, we'll see how Power BI allows us to generate insights on tiles in a dashboard. What I'm doing here is just selecting all of the visuals here from this report that I find interesting and pinning them all to the same AWS SaaS Sales Insights dashboard. And I'll quickly arrange all of these visuals here in this dashboard so you can see what they are. Now, you might say that these are the same visuals that I had in the report and now I have them in a dashboard. Will the insights be any different? Well, it turns out the way the AI algorithm works is that the insights are indeed different. Click on the three dots that show up when you hover over a dashboard tile. This will bring up a menu, and here you should find an option to view insights. This will allow us to view insights associated with this time series chart. And you'll find that the insights here are actually different. There are different charts that allow you to visualize your data in a different way. The first one here is a scatter chart of sales and profit based on order date, and on one particular day, there is an outlier value in sales and profit. You can see the types of these insights are different, and this allows you to extract different information from your data. Observe the narrative summary next to each chart. Sales and quantity have outliers for certain order dates. The outliers are highlighted in red. Our original chart here, the time series chart, is sales over time, and these insights that have been extracted show you the relationship of sales with other columns in your dataset. For example, sales and discount by order year, and you can see both are trending up. As I scroll down, I notice another line chart, sales by customer ID, and you can see that there are certain customers who are outliers. The insights generated in dashboard take the variable that you're interested in, sales, and find the relationship of sales with other variables that exist in your data. Here is sales by segment, and you can see SMB has the highest. And then if you scroll down further, you'll find a bar chart with sales by country, and you can see United States and the United Kingdom are both outliers. They contribute the most to sales by country. It should be very obvious to you by now that it's a different AI model that's run to extract insights from these visuals here pinned to your dashboard. These insights are much more about relationships. Let's view insights for this sum of profit card. And here you can see that we'll see profit as it relates to other variables. Here is a line chart showing you profit by customer ID, and you can see certain customer IDs are incredibly profitable and others are not. Profit is the variable we are interested in, and here you can see how profit changes over years. Profit is clearly trending up, which is great. The most interesting variable in this visual is the profit, and profit is analyzed against all of the other variables in our dataset. Here is quantity and profit by order year, and you can see there is a linear relationship that exists between the two. As you scroll down further, you can see profit by region, and you can see that EMEA contributes the most to profit. Let's go back to our pinned tiles here in this dashboard. I'm going to hover over the three dots for the tree map and view insights for the tree map. If you remember, within a report, the tree map offered no insights, but here the insights generated are different, and you can see how sales and product relate to other variables in your dataset. Since the stream map visualizes sales, here is a line chart of sales by customer ID and sales and count of city displayed as a scatter plot. Getting general insights from your data is useful because that may allow you to find patterns that you may not have known exist or identify relationships that were previously unknown to you. But what if you are viewing some kind of distribution and you're kind of curious about why a particular value increases or decreases in a certain category or period? You can use AI powered insights in Power BI in order to understand fluctuations in your data. You'll be able to drill down into sudden increases and reductions in your data. Here I am on Power BI desktop in a report called Fluctuations and Varying Distributions. Let's go ahead and import the data that we're going to be working with. This is the same global superstore data, but I'm going to be working with the cleaned data set, so we won't need to perform any data transformation or data cleaning. We directly have the cleaned data, and that's what I'm going to load into my Power BI desktop. Once the data is available in my report, I'm going to plot a very simple stacked column chart. And in fact, I'm not even going to stack different categories. This stacked column chart is going to display my sales information, that is sum of sales across different quarters of the year. So select the sales field and drag that to be on the y-axis. You can see the total sales here. Now select the order date field, and you can see that Power BI has automatically set up a date hierarchy for us. Here in this date hierarchy, I'm not interested in the date in very granular form. I'm only interested in the year and quarter information. I select both of these and notice these have been populated along the x-axis of this stacked column chart. And what we have here is the sum of sales by year and quarter. And you might start seeing some patterns here. Often you'll see that quarter three's sales are lower than quarter four. And this is true for the year 2013 as well. Let's say you're curious about why exactly this happens. What changed between quarter three and quarter four in the year 2013? The sales in quarter four were higher than the sales in quarter three, and you want to understand why this increase actually occurred. Make sure you're hovering over quarter four 2013. Right click as you hover over that bar, select the Analyze option and select Explain the increase. Explain the increase will actually look to see why the bar for quarter four is higher than the previous bar in the series that we've plotted, the bar for quarter three 2013. This analysis will compare the bar that we have highlighted with the data point just before it in the sequence, Q3 2013. And let's take a look at this analysis. Now, here are some visualizations showing you why sales might have increased between Q3 and Q4 2013. So, the original chart was sum of sales by year and quarter. The first explanation here adds in an additional variable, the country. And this waterfall chart identifies how the different countries' contributions led to an increase in sales. Now, this first bar here in blue is the bar for Q3 2013, and this last bar here is the bar for Q4 2013. And all of the bars in between here in this waterfall chart shows you the contributions of the individual countries. You can see here that products sold to the US was a major contribution to the increase in sales quarter on quarter. Products sold to other countries other than a few big ones also contributed. Sales to Australia also showed an increase and that contributed. and sales to Nicaragua also went up. And in red, we have countries where sales fell. For example, sales fell in India and sales fell in Italy. These had negative contributions. And this is what led us to the total increase in sales for quarter four. This uses an additional variable country to identify how the sales changed. And you can visualize the same information by means of a scatter plot as well. The green in the scatter plot contains countries which contributed to an increase in sales: United States, France, Spain, and so on. And the red area shows countries which contributed to a reduction in sales: India, China, Germany. You can hover over the individual data points here and see what the sales numbers were for these different countries. So we use the country variable to explain how sales changed. We can also drill down into sales contributions by country using a stacked bar chart. The size of the bar indicates the contribution of each country, and different colors represent different countries. Here is Italy in quarter 3 2013, and you can see that Italy's contribution really fell in quarter 4 2013. The country depicted in blue is China. You can see China where it was in quarter 3 and where China was in quarter 4. There was a slight increase in sales. Let's go to the ribbon chart. This I find the most interesting chart of all. The width of the ribbon on the left and the right indicates the increase or reduction in sales, and the position of the ribbon indicates the ranking among countries. Here is China with the third highest sum of sales in quarter 3. It's still at third highest, and the sales amount increased just slightly. Here is India, whose ranking has changed between the two quarters. It was the fourth highest in sales in quarter 3, but in quarter 4, you can see the ribbon is at number 5. Its ranking fell by 1. Similarly, you can examine the other ribbons here and see how the contributions and ranking changed between quarter 3 and quarter 4. And this goes a long way in figuring out why the sales numbers were different or why they increased between quarter 3 and quarter 4. Here is another visual which shows you how sum of sales changed based on market. In addition to quarter and year, this waterfall includes a third variable, and that third variable is the contribution of different markets. And here you can see the original value. The US market contributed a lot towards the increase in sales, as did the Latin American market, the two green bars. And again, the same visuals you can view using a scatter chart, so you can see what markets contributed positively and negatively to sales. And of course, the stacked bar chart or the stacked column chart gives you the same information. Here you can clearly see the increase in size of the US market from quarter 3 to quarter 4. Next is the ribbon chart, where you can see how the contributions changed and how the ranking of different markets changed. You can see EU, which had the second highest size of sales in quarter 3, fell to a ranking of 3 in quarter 4. Now that you know how to interpret this analysis, I'll leave it to you to explore on your own. As you scroll down, here you find sum of sales by year, quarter, and state. So, state is the additional variable. Here, further down, you can see year, quarter, and region. So, there is an additional variable region which explains why your sales numbers changed quarter on quarter. AI analysis and insights in Power BI allow you to drill down into why your distributions vary, allowing you to drill down and get deeper insights into your data. There might be other variations here in this distribution that you might want to drill down into, and you know how easy that is now. If you notice, quarter 1 in 2014 had a significant fall in sales as compared to quarter 4 in 2013, and this is something I want to drill down into. I hover over the bar that I'm interested in, I go to Analyze, and notice there's an option here that says Explain the decrease. Power BI has identified that this bar represents a lower value of sales as compared with the previous bar in the sequence, and this is what it will now drill down into. Select this option and you will see the different variables that cause this decrease in sales and could be an explanation for why sales fell. The first chart here uses the variable market to identify why sales fell, and the narrative summary tells you that LATAM and US accounted for the majority of decrease amongst the markets. The first blue bar is sales for quarter 4 2013 and the last blue bar for quarter 1 2014, and the US and LATAM contribute to most of this fall. If you look at the scatter chart, you'll find that all of the different markets are in the red zone. So all of them had a negative contribution towards sales. Sales in all of these countries fell in the first quarter of 2014 as compared with quarter 4 of 2013. All of the markets here are plotted in the red zone of the scatter plot. Similarly, the stacked column chart paints a similar picture. The sales numbers in every country fell between the two quarters, and the ribbon chart shows us the exact same thing. Notice that for this decrease, the market variable was considered to be the most significant, and that's why the charts for market appear first. But if you scroll down here on this pop up dialog, you'll be able to see other factors. For example, here is how the different regions that the global superstore serves contributed to this fall in sales. Here is how the different countries contributed to the fall in sales, and here is how the different cities and different subcategories contributed to the fall in sales. You can see that sales fell across almost every subcategory of items. So here is quarter 4 2013, sales fell for accessories, sales fell for chairs, sales fell for bookcases, and all kinds of products. Notice all of the different subcategories are in the red zone of the scatter plot. Well, this should give you enough insights into why sales fell quarter on quarter from Q4 2013 to Q1 2014. So far, we've been able to drill down into changes in the distribution from one point in the sequence to the next for consecutive points. Well, it's not necessary that you can only work with consecutive points. Let's say you're curious about quarter 1 in 2013 and sales in quarter 1 of 2014. You can see that there is a difference, and you want to understand what causes this increase. What caused the increase of sales in quarter 1 2014 over quarter 1 in 2013? I've selected the two bars that I'm interested in. I'm going to right click, analyze, and there's an option here, explain the increase. The Q1 over Q1 increase, that's the explanation I'm looking for. And subcategory is the first graph that shows up here. There were clearly certain subcategories that contributed significantly to this increase in sales. The first green bar shows me copiers. Copiers sales shot up year over year. Then there are chairs, sales also increased due to chairs, and phones seem to have contributed positively as well. There was a negative contribution from tables. The sales of tables fell year over year. So Q1 of 2014 had fewer sales of tables as compared to Q1 of 2013. The scatter plot shows you a quick overview of all the different subcategories and their contributions. Copiers is an outlier in positive contribution, and tables is an outlier in negative contribution. You can see there are more positive categories than negative categories, leading to an overall increase in sales, and the ribbon chart gives us the same information. Here you can see that the sales of bookcases fell. Bookcases was at number 1 in quarter 1 2013, but bookcases fell to number 4 in quarter 1 2014. If you're running the global superstore, all of these insights you might imagine are very, very useful in order to understand why your sales distribution varies. You can see variation here by year, quarter, and city. And as you scroll down further, you'll see variations by year, quarter, and state. So you can drill down into regional variations as well and see how the different city, state, country, etc. contributed towards the increase in sales. Well, at this point, you should be very comfortable trying to figure out why your distributions vary by using AI powered analysis. I'm going to get rid of this chart that we see here on screen so that we can explore fluctuations in our data with some other charts in the video coming up next. While you're analyzing and exploring the visuals that you've generated for your data, you might land up with certain questions in your mind. You might look at a data point and wonder whether the distribution for this data point is the same across different categories and different subpopulations in your data. Now, if you had to set up a visual for all of this to actually drill down further, well, that's very time consuming and onerous, and you may not get all of the underlying factors that affect a particular distribution. With AI insights in Power BI, drilling down into what categories or variables affect the distribution of a data point is very, very simple. Let me show you how. I'm going to set up a clustered column chart here to display the sales across different categories. Along the y-axis, representing the height of the bars, we have sum of sales. So select the sales field and drop that into the y-axis section. Along the x-axis, I'm going to select the categories of products sold by the global superstore. Observe that we have three categories: technology, furniture, and office supplies. What we have here is total sales by category across all of the countries and continents served by the global superstore. You can see office supplies has the lowest value of total sales, furniture comes next, and technology products are at the highest sum of sales. Now, you might look at this bar chart and say, is this distribution the same across all regions, all markets, and all countries? I'm curious to find out whether technology always outperforms furniture and office supplies, and furniture always outperforms office supplies across all subpopulations. Now, you can, of course, do this manually. You can apply filters and then compare the different distributions, but that's time consuming and error prone. Why not just turn to AI powered insights in Power BI? Right click on this particular chart, choose the Analyze option, and select the option here that says find where this distribution is different. Now, AI algorithms will run on your data, identify all the different variables that affect the sum of sales by category, and show you those variables where the distributions differ. And the first variable that significantly affects the distribution and where the distribution is different for sum of sales across categories is the market to which Global Superstore sells. And the three markets here are EU, APAC, and Africa. Let me explain how you can interpret this chart before we drill down further. Observe that EU as a market has been selected, so the blue bars that you see represent the total sales in each of the three categories for the European Union. In addition to the three blue bars, notice that we have a gray dotted line and shaded areas under the gray dotted line. That represents the distribution of the three categories, that is, total sales across three categories for the entire data set. The gray dotted line is at the highest level for technology, next for furniture, and then for office supplies. That represents the global distribution of this data point. Observe that this chart has two y axes, one on the left and one on the right. One on the left represents the sum of sales for the European Union, and it varies from 0 to about 1.2 million. The axis on the right represents the total sum of sales, and that axis goes from 0 million to about 4 million. The descriptive text on top of each visual indicates the level of importance that can be applied to this particular filtering that has been used in this visual. Here, the filter is by the European Union, and you can see that the European Union comprises of 19.5% of the records in the entire dataset. So while the distribution of total sales is different for the European Union, it accounts for only 19.5% of the total records. You can hover over the individual bars here and get the exact sales numbers for each category of products sold. For example, furniture is at about 779,000 and office supplies is at about 1.04 million. At this point, you should have a good idea of how you can actually interpret this visual. Before we look at the other markets, APAC and Africa, let's look at some other variables based on which this distribution varies. The distribution of total sales by category also varies by region, though the regional variations are less significant than the market variations. And the reason for that is look at the narrative summary up top. The description says Africa has just 8.9% of the records, Central Asia 4%, and North Asia 4.6%. The proportion of records for these different categories are smaller, so even if the distributions are different, the differences are less significant. Let's just look at this particular distribution for Africa. In the overall distribution, technology has the highest total sales, furniture second, office supplies third, Furniture forms a much smaller proportion of the total sales in Africa. Technology and office supplies are bigger. Let's scroll further down, and here is another variable based on which the distributions are different: country, specifically Brazil, Germany, and France. You can see that for Brazil, the furniture category forms a greater proportion of the overall sales than for the entire distribution, where furniture is in the middle, technology is much higher. Let's scroll back up here and focus our attention on the variation of the distribution based on market. We've already analyzed the variation for EU. I'm now going to change the filter and I'm interested in viewing the distribution for APAC. Here you can see that total sales for technology and furniture are at par, they're equal to one another, and office supplies is much lower. In order to identify these different variables based on which the data is filtered, the Power BI algorithm applies a bunch of filters and then checks to see for which filters the distributions are significantly different from the overall distribution. Now, what does different mean? For simple additive measures such as total sales, the algorithm looks for differences in relative value. The relative value of furniture sales is quite different for APAC as compared to the relative value of furniture sales in the overall records. Let's see how this distribution varies for the Africa market. And here you can see that the furniture category is relatively less important than technology or office supplies. Not only can you visualize and analyze how these distributions are different for different subpopulations, you can also pin these visuals to your report. You can click on this little plus button and add this visual to your report page. And this allows users to view interesting insights in your report. Not only can they see the overall sales by category, they can also visualize how the distribution is different for the EU. Let's go back and analyze and find where this distribution is different once again. I'm now going to apply APAC as a filter and add this particular visual to my report as well, so that I can view how the distribution is different for APAC as well. So now we have EU and APAC. Once again, let's go to analyze and find where this distribution is different. And I'm going to apply the third market filter, Africa, and add this visual to my report. So now we have the three different markets, and we can see how the distributions are different for total sales by category. Now that we have a report nicely configured, let's look at some of the options that we can configure when we visualize how our distributions vary. Now, right click on the same bar chart once again, go to Analyze and go to Find where this distribution is different. And this pops up the same analysis that we looked at in a lot of detail just a few minutes ago. You can see how this distribution is different based on different categories: ship mode, country, city, and so on. Now, let's scroll down further to this segment variable. The global superstore sells products that belong to the technology, furniture, and office supplies categories, and all of these sales are to customers who belong to three different segments: home office, corporate, and consumer segments. Home office is the segment currently selected, so the blue bars represent sales to the home office customer. And you can see the distribution here matches the overall distribution. Technology sales are the highest, office supplies the lowest. If you remember, I'd mentioned earlier that this chart has two different y-axes, one on the left and one on the right. The one on the left represents the sum of sales for home office, so only for the filter that's applied. And the y-axis on the right gives us the total sales across all of the records, across all of the segments. The distribution of the total sales across all categories is represented by the dotted gray line that you see here on screen at different heights. If you look at the description on top, the home office segment makes up only about 18.2% of the records. This means that sales to the home office segment should roughly be 18.2% of total sales across all categories. Let's switch over to filter by corporate. You can see here corporate comprises of 30.1% of all of the records across the dataset. Again, we have the two y-axes, sum of sales for corporate on the left and total sales on the right. The distribution for corporate customers across the three categories is the same as the overall distribution. Let's take a look at the third and last segment available here, the consumer segment, and the distribution for the consumer segment again is the same as the overall distribution. And we have the two y axes as before. It's pretty clear here that the bars for the different filters fill up the entire space, and you can't really see what proportion the home office sales is compared to overall sales across all segments. And the reason for that is by default, we compare the distributions for different subpopulations based on proportions. If you look at the little slider at the bottom, notice that it's comparing by proportions. Now you can actually switch this around and compare using absolute values. The visual is now significantly different. You can see the total sales, those are represented by the dotted gray line, those are much greater than the sales in the home office segment. The bars of the home office segment sales are much smaller because we are now representing the absolute values of sales to the home office segment in relation to the total sales. We are not just comparing proportions. Also, note that we now have just one y axis to the left, which represents the total sales, and the sum of home office sales is represented in the same axis. Comparing using absolute values will give you an idea of what proportion of the sales go to that particular segment. When you compare only using proportions, you see the overall distribution and you have to look at the description to know the proportion of records for a segment. But here you can see the bars as they compare to the overall sales for each of the segments: home office, corporate, and consumer. So you can also choose to compare using absolute values and not just proportions. All of these are just different techniques you can use to drill down into your data to understand what variables affect the distribution of a data point. I'm going to go back to comparing proportions here. You can actually represent this data in a more interesting way. Observe that we have the overall sum of sales by category. I'm now going to add market to the legend of this particular chart. So I have a clustered column chart. And now I have the same information expressed in two ways. Notice the sum of sales for the category furniture in the EU. Well, I have a bar representing the same information as well. And you can see it represents the same value. In this demo, we'll see how you can use text analytics within Power BI. Text analytics allows you to harness the power offered by Azure Cognitive Services. Azure Cognitive Services is a suite of cloud-based services and APIs provided by Microsoft through its Azure Cloud Platform. These services allow developers to incorporate intelligent algorithms related to speech, language, vision, decision making, and many more. Azure Cognitive Services makes available several APIs allowing you to work with vision. Vision APIs allow you to detect faces, identify objects and images. Speech APIs perform conversion, speech to text and text to speech. Language APIs offer text analytics, extracting insights, sentiment analysis, key phrase extraction, language detection, translation, and so on. Here in Power BI in this demo, we'll see how we can harness the power of text analytics. We'll start with language detection. Now we'll import the data that we'll use for this particular demo. It's available as a CSV file here called language detection, and it contains text in a number of different languages. I downloaded this language detection dataset from this URL here at Kaggle, and then I applied a randomizing function to randomize the order in which the languages were presented. So the language data here is actually shuffled. All of the text in a single language don't appear together. So you can see we have two columns, column 1 and column 2, one containing text and the second one containing the language. Now, language detection is available as a part of the Power Query editor. So click on Transform Data and this will take you into the Power Query editor. We'll need to do a little bit of pre-processing on this data, and that pre-processing has to do with column headers. Notice that the column headers are column 1 and column 2, but the first record contains the actual headers for this data, text and language. I'm going to click on Use First Row as Header, and you can see that we now have the right column headers. And with text data, that's the only bit of pre-processing I need to perform. I'm going to click on close and apply, and this data set has been loaded into my Power BI report. And you can see here that we have two columns of data, text in a variety of different languages, and we also have a language column identifying what language that particular text is in. And we have a number of different records. You can see we have about 750 records. Let's head back to the report view and let's quickly understand the data that we are working with. I'm curious about how many different languages we have here in this dataset and how many records in each language. And I'll visualize this using a clustered column chart. We have a language column that categorizes the text in this dataset as being in different languages. So I'm going to drag that onto the x-axis and I'm going to drag the text field onto the y-axis. The only kind of aggregation you can perform on the text field is to count the number of text records, and you can see that there are an equal number of text records in different languages. There are 50 records for each and 750 records in total. This means that there are 15 different languages represented here in this dataset. We'll have Power BI detect the language of the text in each record by only looking at the text column. Click on Transform Data so that this brings up the Power Query editor. The text analytics feature in Power BI is available as a part of Power Query. And here you can see the data that we have. Observe the different languages. Now I noticed that Portuguese and Swedish are both misspelled. Portuguese is spelled with a double E, and Swedish, not really seen here in this screen, is also spelled with a double E. We can ignore this. We won't really be using the language column. We'll only be using the text column for language detection. At the top right, notice we have a button for text analytics. Text analytics here in Power Query connects to a number of different APIs in Azure Cognitive Services. And one of those APIs happens to be the language detection API that can detect the language in a document and return a language code. And this works for a wide range of languages, variants, dialects, and even some regional cultural languages. When you click on Text Analytics, you'll be asked to log in to your Power BI account. Now, I wasn't logged in, so I'm going to sign in and I'm using the user Power BI at lunicorn.com, and I use that to connect to the Power BI service. And this is what will make available the Text Analytics APIs. Observe that there are three different APIs available for us to use: detect language, extract key phrases, and score sentiment. Let's start with detect language. We are presented with a dialog where we indicate whether we want to enter the text whose language we want to detect or whether the text is present in a column in our dataset. Select the column name option. That's what is selected by default. And using the drop down, specify which column contains the text. The name of the column that contains the text in different languages is just the text column. Make sure you select that option and click on OK. When you use the text analytics APIs, you need to provide information about your data privacy levels. Click on Continue, and this brings up a dialog. This is to ensure that you don't pass data that you don't mean to the text analytics API on Azure Cognitive Services. Here, I'm going to select this language detection.csv file, which is an organizational file, and set the privacy level to organizational. So this data won't be publicly accessible. So go ahead and save the changes to this dialog. Now it took about a minute for the language detection API to return a response for all of the text we had in our dataset. And there is the response from the API. You can see language, that was the original column. Off to the right, we have the detected language. And for each detected language, we also have the corresponding ISO code. If you look at the detected language and the actual language values in the original dataset, you'll see that for the most part they match. You can see on row 13 that Swedish is spelled correctly in the detected language, as is Portuguese on row 21. There doesn't seem to be a single instance here where cognitive services got things wrong. But as you scroll down here, there are some cases where there are definitely mismatches. For example, row 540, the original language was Danish, the detected language was Norwegian. And in this dataset, I did feel that cognitive services made a number of mistakes detecting the Danish language. I've brought up the filter dialog on the language field and I'm going to deselect all languages here and I'll select a few languages of interest. This includes Danish. Let me scroll down. I'll also select Russian, I'll select Hindi, and I'll select Swedish. Now, only the records for those languages will be visible, and a quick glance shows me that there are very few mistakes in the languages detected. But here is one. Notice row 51 here. The detected language was unknown, and the original language was Russian. That particular record contains very little text, and maybe that's why that wasn't enough for cognitive services to detect the language correctly. Further down, I identified a mistake that cognitive services made. The original language was Danish, but it identified this record as Norwegian. If you want to get a big picture of how many miscategorizations there were, go ahead, close and apply these changes. The data will be updated with the detected languages from cognitive services. Now I'm going to get rid of this x axis here, and instead of language, let's choose the detected language and place that field here in this x axis. Observe that all of the bars are now not of the same height. 52 records have been identified as English. The original only had 50. And if you kind of hover over the remaining bars, you can see that 2 records have been identified as Norwegian, whereas there was no Norwegian text in the original dataset. You have to admit that language detection using text analytics in Power BI was very straightforward. Let's bring up the Power Query editor once again. Click on Transform Data and observe on the left navigation pane under Queries, you have a function Detect Language that is now available. You can actually directly invoke the Detect Language function on input text of your choice that you enter here in this input text box. The first bit of text I've entered here is in the Spanish language, and I'm curious to see whether Power BI will identify this. Click on Invoke, and the Cognitive Service API tells me the code is ES, language name Spanish. Okay, that was good. Let's go back to the detect language function, and this time I'll enter some text in Italian. Go ahead and hit Invoke, and this was also correctly identified as Italian. Back to detect language, let's go ahead and enter some text. This time it's in French, and this was also correctly identified as French. Now, one last language that I want Power BI to identify, this is in Bulgarian, and this was also identified correctly. Well, now you have some hands-on practice using the language detection API, part of the text analytics that Power BI supports. Here I am on a new page in the same Power BI desktop report where I was working earlier. This is the text analytics report and I am on page 1. The first page I've renamed to language detection. We'll now see how we can perform key phrase extraction from our text using the text analytics feature here in Power BI. Key phrase extraction, also known as keyword extraction, is a natural language processing technique that involves automatically identifying and extracting important and relevant phrases or terms from a given text. These key phrases are used to identify important themes and topics in the input text. Now, for key phrase extraction, we'll work with a new dataset. Click on Get Data Text CSV and select the IMDb rating dataset. This IMDb rating dataset contains reviews for a number of different movies. This is a dataset I downloaded from this original URL here at Kaggle. Key phrase extraction in Microsoft Cognitive Services works best when you give it bigger chunks of text to work on. Whereas with sentiment analysis, which is what we'll do next, sentiment analysis works better with smaller pieces of text. So I chose a data set where the reviews were fairly large and detailed. Go ahead and load this data in. The data is now part of our report. Click on the table view so that we can take a look at this data. We have the language detection dataset and the IMDb dataset both in this report. And you can see that the text here is fairly large. Every review is fairly detailed. Click on the transform data option so that this brings up the Power Query editor and that will give us access to the text analytics feature. Make sure you have the IMDb rating query selected because this is what we want to operate on. And let's get right to it. Click on the text analytics button available here in the top right of your screen. Since we already logged in the previous demo, we were not prompted to log in once again. Select the Extract Key Phrases option here. You'll need to specify what column in your dataset contains the text. It's the text column, so nothing to change here. You can also specify what language your text is in. This is completely optional. Azure Cognitive Services should be able to detect the language that you're working in and extract keywords or key phrases based on that language. Once again, you'll need to specify data privacy levels. Click on Continue and make sure you select the CSV file that you're using to actually perform text analytics. Once again, I've specified privacy level as organizational. Go ahead and save. Text analytics should run, and in a few moments, you should find the key phrases in each of your reviews. You might notice that each of the original reviews is repeated multiple times. You can see the first review here is repeated more than 20 times. And observe here the key phrases that were extracted from this review. Now, each key phrase that was extracted is available as a comma separated list in the Extract Key Phrases column. It's also available as a separate key phrase in the Extract Key Phrase.key phrase column. School was the first key phrase extracted, and we have school in the first record. Thunderbirds was the second, Thunderbirds in the second record. Homo sapiens is the third, Homo sapiens in the third record, and so on. The data has been transformed so that you now have multiple rows for each review, and each record corresponds to a key phrase that has been extracted from that review. We've successfully extracted the key phrases in our dataset. Go ahead and close and apply the changes. Our data has been enhanced with these additional columns, with the key phrases as comma separated values and as individual words. Let's analyze the frequencies of the different words that were extracted across all of the reviews. Here I have a clustered column chart, and on the x-axis I'm going to place the key phrase column. This is the key phrase column where we have the individual words, not the comma separated value. And along the y-axis, I'm going to place the count of text. Here you can see the frequency of the different key phrases extracted. The most common seems to be BR. Now this seems illogical, but if the original text were in HTML, BR could refer to the line breaks. So that's just an HTML character and we can ignore that. The most common word seems to be time, and 173 reviews contain this term. The next most common seems to be movie with 162 occurrences, and you can scroll over to the right and see some of the least common words. A better way to visualize the frequent key phrases that occur in your text is to not use a bar chart, but instead use a word cloud. Now, a word cloud is not present as a built-in visualization here in Power BI. But you can access more visuals from the Power BI App Source Marketplace. Click on the three dots, select Get More Visuals. This will bring up the Power BI App Source visuals. And here in the search box on the top right, just search for Word or Word Cloud. Select this Word Cloud offered by Microsoft Corporation. And you can see it's also well rated. 4.2 is the rating. This is what a word cloud looks like. The more frequent words are present in large font sizes. Words that occur less frequently in the text are in small font sizes. Go ahead and click on the Add button to add this visual to your Power BI report. And once the visual has been successfully imported, you can find it there in the visualization pane, select it and add it to your main canvas. Now, using a word cloud is very straightforward. Simply select the key phrase column. This is a column where each key phrase is present as a separate field, and drag that into the category section here in this word cloud. Let me just expand the data pane and show you what column I selected. This is the Extract Key Phrases dot key phrase column. And you can see that the word best occurs very frequently. That's why it's in the large font. Big, bad, American, better, those are terms that occur frequently in the review. Words in small fonts such as things, versions, angel, award occur less frequently. Let's rename this page to be called key phrase extraction, and we'll do one last bit of exploration before we move on to the next feature in text analytics. Click on transform data and On the left in the query section, notice we have a function for extract key phrases. You can actually write in your text here and extract the key phrases in your text. I've added in some text there which describes Power BI, and when you hit invoke, you'll be able to see the key phrases that were extracted from that bit of text. And here is the original text on screen as well. Let's try this once again with a different piece of text. Now, this text describes generative AI, and here are the key phrases that were extracted. And let me expand the function editor so that you can see the original text. Well, you've successfully performed key phrase extraction using the text analytics feature in Power BI. Here I am on a new page in my text analytics report that I'm creating using the Power BI desktop. This time we're going to be performing sentiment analysis on our text using the score sentiment function. This evaluates the text input and returns a sentiment score for each document, ranging from 0, that is negative sentiment, to 1, that is positive sentiment. I have my reviews data here as a CSV file on my local machine. Click on Get Data, Text CSV, and we are going to be working with the restaurant reviews dataset. Now, sentiment analysis is performed on the entire input text field that you specify. So, sentiment is not extracted for a specific entity. Also, sentiment analysis in Power BI works well with shorter snippets of text. Here is the original source on Kaggle where I found this restaurant reviews dataset. For the most part, the reviews are fairly short, so I thought this was an ideal dataset for sentiment analysis. Now, in addition to the review, notice that we also have a liked column which indicates the sentiment of the review. We'll use this liked column in our dataset to evaluate how our sentiment scoring algorithm did. Go ahead and load this data, and let's take a look at the table that we've just loaded in. The first column contains reviews, and all of these are restaurant and food based reviews. And the second column, liked, indicates whether the review was positive or negative. 0 negative, 1 is positive. I'm curious about the average sentiment score across the entire dataset, and I'm going to visualize this using the card visual. Go ahead and add a card to the report, and in this card, I'm going to compute the average liked score. The average liked score will give me an indication as to whether the reviews are mostly positive or mostly negative. Now, instead of sum of liked, I'm going to compute the average of liked, and you can see the value is 0.5. This means that we have an equal number of positive and negative reviews here in this dataset. And this is something you can confirm using another visual, the pie chart. Add a pie chart to this report, and I'll use this pie chart to display the proportion of positive and negative reviews. So let's place the count of reviews in the values section, and let's place liked in the legend section. And this actually makes it very clear that we have an equal number of positive reviews and negative reviews. We have 500 plus 500, a total of 1000 reviews in our dataset. With this in mind, let's use the text analytics feature to perform sentiment scoring for this dataset. Click on Transform Data and select the restaurant reviews query on the left navigation pane. Our review column is the one that's selected. Click on Text Analytics to perform sentiment scoring. This will bring up the dialog where you can select what kind of analytics you want to run. Score sentiment is the function that I'm going to select this time around. This will bring up a dialog where you select the column that contains the text that you want to compute the sentiment for, and you can optionally specify a language. Well, review is the only such column available, so that's what we select. Go ahead and click on OK. And once again, you'll be asked to specify the privacy level for this particular data that you want to analyze. Click on Continue. Make sure you select the restaurant reviews CSV file, and I've set the privacy level to organizational. Wait a few moments for the sentiment scoring to be done, and you should get a score for every review in your dataset. Observe that these scores are not 0, 1 values, but instead they are decimal numbers. These raw scores indicate how positive or negative a particular review is. The score for the first record, 0.99, indicates it's highly positive, whereas the score for the second record, 0.04, indicates that it's highly negative. Scores close to 0 are negative, Scores close to 1 are positive. Here's a review. The worst was the salmon sashimi, that's clearly negative, and you can see it has a score of 0.139. Here is an interesting review in record 41. The shrimp, tender and moist. Observe that it has a sentiment score of zero point 0.5, which seems mostly a neutral review. Not really very positive, not very negative either. Let's say you don't want these raw probability scores. Instead, you want a prediction. You want the model to say 0 if it's negative sentiment or 1 if it's positive. Well, you can achieve that very easily with a little bit of math. Let's set up a custom column called predicted sentiment where we'll round the probability score, that is the sentiment score generated by the text analytics model. The values in this new column that I'm about to set up will be computed using the number.round formula that will operate on the score sentiment column. This will categorize any raw score greater than zero point 0.5 as 1, that is positive sentiment, and scores zero point 0.5 and below will be categorized as negative sentiment. So record 3 with a score of 0.008 has been categorized as negative 0. Record 7 with a score of 0.82 has been categorized as 1 positive. Record 8 with a score of 0.5 has been categorized as 0 negative. Power Query for some reason hasn't correctly identified the data type of the predicted sentiment column. You can see that the data type is set to any by default. Let's change this to whole number. This will ensure that the predicted sentiment column contains numeric values. These are the only changes we need to make here. Close and apply the Power Query changes. And we now have the predicted sentiment here as a part of our dataset. Let's see how the predicted sentiment score compares with the actual labels in our data. I've added a card visual here that I'm going to use to compute the average of the predicted sentiment. So drag that into the field section and change the aggregation to average. This will give us the average predicted score. In the actual data, the average was 0 0.5, and for the predicted sentiment, the average is still 0 0.5. So it seems like the predicted sentiment is more or less similar to the actual sentiment labels. Let's visualize the proportion of positive and negative text based on the predicted sentiment. I'm going to drag the reviews onto the values field, count of review, and I'm going to drag the predicted sentiment into the legends section. And here you can see that it's not a perfect 50-50 split. You can see that 503 records have been categorized as negative and 497 records have been categorized as positive sentiment. Let's complete our exploration of the sentiment score API by directly invoking the score sentiment function. Bring up the Power Query editor, and on the left we have the score sentiment function. Select that, and here you'll find an input text box where you can enter your reviews and get the sentiment for those reviews. Hit invoke and get the sentiment score. You can see it's 0.07. So it's overall negative sentiment, and you can see the entire text of the review here. Let's try this once again with a different function. There is room for improvement in the menu variety. This doesn't seem very positive, but yes, it was indeed a positive review. The meal was decent and I enjoyed the ambience. The score is 0.98, which indicates a very positive review. Let's try one last review, which is more or less average. So the dining experience was neither exceptional nor disappointing, it was just decent. And this gets a score of 0.87. In this demo, we'll see how you can use vision functions in Power BI to perform image tagging. The tag images function returns tags based on more than 2000 recognizable objects, living beings, scenery, and actions. If the tags generated for an image are ambiguous or not common knowledge, the output provides hints to clarify the meaning of the tag in the context of a known setting. Tags have no hierarchy or no specific taxonomy. Multiple tags can be associated with the same image depending on what is depicted in the image, and these tags together help provide a description for that image. Let's get the data for images that I have stored here in a text CSV file. Now, this is a data set that I created myself. I just put together a number of image URLs and created this image URL dataset. All of the images are from pexels.com. which allows us to use their images license free. When you first load this data into your Power BI desktop report, you'll see two columns, column 1 and column 2. Column 1 contains the protocol for the URL, and column 2 contains the rest of the URL. Don't be phased if this happens. This is because the delimiter chosen by default is the colon, which is why it splits the image URL into two, protocol and the rest of the URL. Choose the comma as a delimiter, and you'll be left with a number of image URLs, and we'll use these as an input for the tag image function available in Microsoft Cognitive Services. Click on transform data. There is a little bit of data processing that we need to perform. We just have the one column here in our data set, and by default it's named column 1. I'm going to select the use first row as headers property here, so that URL is the name of the column. Close and apply these changes and wait for the data to be loaded into your Power BI report. Now, it's quite possible that your images are part of a larger dataset with many more columns. To keep things simple, I've just generated a number of image URLs for images on the pexels.com site. Let's go back to our report and let's see how we can tag these images. But before we get to using the cognitive service Vision API, let's set up a table, and I'm going to place all of the image URLs here in this table. Select and drag the URL field in the image URL dataset to the table, and here you can view all of the URLs I have in my dataset. You're welcome to click on any of these URLs and open these up in your browser to see what these images look like. But for me, I'm going to keep the element of surprise. I'm going to view the images once I generate the tags. The Vision APIs are accessible via Power Query. Click on Transform Data, and this brings up the Power Query editor. And off to the top right of your screen, notice the Vision button. This is what allows us to access the Vision API. Go ahead and click on this. The only Vision function available at this point in time from the Cognitive Services suite is Tag Images. This will bring up a dialog. In the image field here, you'll need to specify the column in your dataset that contains the image URL. That happens to be the URL column for us. In addition, you can generate tags in different languages. Currently, the supported languages are English, Spanish, Japanese, Portuguese, and Simplified Chinese. Once again, if you're sending data to the Cognitive Service APIs, you'll need to specify information about the data privacy level. I've set the privacy level to organizational once again for my image dataset. Once you hit save, the image tagging API will do its magic and generate tags for each of the image URLs you have here in your dataset. Let's take a look at these additional columns that have been added to each image URL, starting with the first one. The first column contains the image tags. Now we can't see the image, so we don't know whether these tags are accurate or not. We'll verify that in just a bit. Meanwhile, let's take a look at the tags. The first thing to note here is that every record in the original dataset has been duplicated as many times as the number of tags generated for that image URL. You can see that the first two records correspond to the same URL. This URL has two tags specified as a comma separated list, indoor and surface. The next URL corresponds to records 3 and 4. You can see the URL is the same, and there are two tags for this image as well, wall and indoor. Now that we've seen the tags as a comma separated list, let's see what other columns have been added. The tag images.json column contains the confidence score for each tag the image URL has been annotated with. The individual tags on the URLs are present in the tag images.tag column, and the confidences for each tag are present in the tag images.confidence column. For the very first image, the confidence score for the indoor tag is 0.87. So the model is fairly confident that this image represents something indoors, and the confidence score for the surface tag is 0.57. So lower than the indoor tag, but still pretty high. For the second record, the confidence score for the wall tag is 0.99. So the model is really confident of this tag, and the confidence for indoor is 0.87. Again, quite confident. If you scroll over to the right, you'll find another column called tag images.error message. If there was any error accessing the URL and then tagging the images, that error would be present here in this column. Let me just show you the JSON format of the confidences information here in this tag images.json column. Notice that the JSON object contains a single field confidences, which contains a list of confidence scores for the different tags. For the very first image, the tag indoor has a confidence of 0.87, we've seen that, and the tag surface has a confidence of 0.57. We've got Azure Cognitive Services to tag all of the image URLs that we have here in our data, but are these tags accurate? Let's close and apply this Power Query transformation, and then let's take a look at the images here in our data. Here I am in the Power BI report and I have the table visual selected. I'm now going to select the field that I've displayed here within my table, the URL field. Selecting a field brings up all of the operations under the column tool section in my ribbon up here. On top, observe there is a field called data category that allows you to specify the kind of data that you're displaying here in your table. Now, by default, the data category says uncategorized, but you can click on this drop down and select the kind of data you're representing. The data that we have is an image URL. So I'm going to go ahead and select that. And the moment you do this, the table has been updated to display the images that are found at those URLs. Notice that our table now has actual images rather than just the URLs of those images. This is great because now that we can see the images, we can also see whether the tags generated for these images were actually accurate. Select the tag images dot tags and drag that into the columns of the table as well. So now not only do we have the images, we also have the tags for those images as comma separated values. I'm going to format this visual so that I can increase the font size of the tag so we can view it clearly. The images are still kind of tiny, but a quick glance shows you that the tags seem fairly accurate. Observe the image with the tag person woman window. That does seem like a person standing next to a window. And there is an image with a camera which has the tags grass, outdoor, electronics, camera, lens. Again, seems very accurate. And a quick glance over all of the generated tags makes me feel that the image tagging actually worked pretty well. Let's try a slightly better technique of filtering and viewing the tags on the different images and seeing whether they are accurate. I'm going to select and add the clustered bar chart visual to this report. And on the y-axis, I'm going to add in the field tag images.tag. This is the column that contains the individual tags, not the comma separated tags for each image, but the actual tag values. I want the bars in this bar chart to represent the frequency of each tag across all of the images in our dataset. So on the x-axis, we'll place the count of tag images dot tags. I'll go to format visuals for this particular bar chart and turn on data labels so that we can view the frequency information for each of the individual tags. And with this done, let's use some interesting filtering to view images that have specific tags. Now, notice the image tag here, indoor. There are 25 images that have this tag. The second highest frequency tag is for person, and there are 10 images with this particular tag. What I'm going to do here is select a single bar, and this will filter all images which have this particular tag, the indoor tag. And you can scroll down here and see all of the images that have been tagged with indoor. And they do all seem to be indoors. Let's try a different tag. Let me select the person bar. And here you can see all of the images that have been tagged with the person tag. There are fewer images here, but each image seems to have some person in there. Let's try another tag here. Let me select outdoor, and here are all of the images of people or things outdoors. Here is another image with wall, and definitely these are all images of walls. Here is surface. There is just one image that matches this. Here is electronics. There are 4 different images that match this tag, and so on. So you can select the different tags and view the images corresponding to that tag. Here's one the model gets wrong. The tag here is cup, and the second image is of a pair of headphones. That's definitely not a cup, but the model gets it wrong and thinks that it's a coffee cup. The model clearly isn't perfect, but it does a pretty good job. You have now reached the end of this course, Leveraging AI Insights and Text Analytics in Power BI. Power BI offers artificial intelligence based features for many use cases. With the advent of generative AI tools like ChatGPT, Power BI has introduced insights, text analytics, image analytics, DAX query generation, AI powered visuals, and many more AI based features as a part of its core offering. We started this course off by generating insights on data and reports. These are AI powered insights. You saw that we could generate AI based insights of three different types: anomalies, key performance indicators, and trends. We explored how we can generate these insights on datasets in our Power BI service, within our reports, and even on dashboard tiles. We then used AI to explain fluctuations in our data and drill deeper into why our data varies in a certain way. Next, we learned how to perform text analytics in Power BI. Power BI integrates with Azure Cognitive Services to allow for text and image analytics. We explored how to use the text APIs for language recognition. We loaded in a dataset with text in different languages and used this feature to label each language. We noted that the languages identified by the model tended to be correct mostly, but that it did also make a few mistakes in language identification. We also learned how to perform key phrase extraction. We used a dataset with text sentences and then this feature to extract the key terms and phrases used in the text. Then finally, we performed sentiment analysis, generating sentiment scores for reviews. In addition to text analytics features, Power BI also offers image APIs from Azure Cognitive Services. We used the image tagging API that allowed us to label an image with tags with the help of AI. We loaded in a dataset of images and generated tags for each of them. We examined our data and ensured that the generated tags were indeed accurate and meaningful. In conclusion, this course has provided us with a solid understanding of how AI based features can be leveraged in Power BI, enabling us to move on to training machine learning models in Power BI. That's in the course coming up ahead.